Okay, I want to go over a few things before we get started. First is the final. You guys got an email yesterday, and it told you, but the final, I've got to have it turned in by Friday morning. So I'm going to open it tomorrow at 8 a.m., and then it's going to close Thursday by midnight or at midnight. So you'll have more time to take it than before. I believe it was 2 hours and 15 minutes or 2 hours and 30 minutes. I can't remember, but you'll definitely have a lot more time to take it. Of course, there's more questions because it's a final. It's comprehensive. The sections we're going over today and the one we went over yesterday, they'll be on there, but they're not on a regular test, and they'll be all through college algebra. So we'll have to know them. Tomorrow, I've decided to not do 8.3. Instead, I'm just going to have a review session. So you guys can come in and ask as many questions as you want. I'm not going to go over any probably like new material per se. I won't even record it. It's just going to be, if you want to come in and ask questions, I'll record it just because if someone has some good stuff that for the disc, and I'll put it on there. So, but yeah. So tomorrow, no new material, just review, and that way you've got really 2 days to take the final. Okay. Do you guys have any questions for me before we get rocking and rolling on today? Today's lecture won't take long.
I have a question over the homework.
Okay, great.
Number 43 or 47?
43 or 47? 8.1, right?
Yes.
43. Yeah, these are not the easiest, right? Let's just do, I mean, doesn't matter which one. You're right. They're very similar. Let's do 43, okay? So this is 43 on page 596. And you'll see today we're going to go over the quadratic equation. I would use it for 43, but it's a good challenge question. So x squared plus x minus 1 equals 0. So first thing, of course, I'm going to add the 1 to the other side, right? And then I'm going to put the box on both sides. And now I've got to think of the pattern. Remember, there's a 1 here, right? Remember, what goes inside, you just divide this by 2. So it's going to be x plus 1/2. But in the box, you got to square it. Well, 1/2 times 1/2 is 1/4. So on the right, we've got to add 1 plus 1/4. Well, 1 plus 1/4, I mean, that's 5/4, right? It's like 5/4. So we get 5/4 there. So that's really, that's the first kind of tricky part, right? Okay. Then I've got to take the square root of both sides, but do not forget the plus or minus. So when I take the square root of both sides, I'm going to attach the plus or minus. So I get x plus 1/2 equals, now I've got to take the square root of the top and bottom. Square root of the top I can't really take, so I'm just going to say it's the square root of 5. But the square root of 4 is 2, right? And then subtract the 1/2 over. So you get x equals negative 1/2 plus or minus the square root of 5 over 2. But in the book, they combine these, they make this one fraction because we have a common denominator. So when you do that, you've got to make this negative go to the 1. So we get negative 1 plus or minus the square root of 5 all over 2. And those are the two answers. Does that help? Was that Amanda?
Yeah, that I see where I messed up.
Okay. It's okay. And I'm telling you, today I'll come back and answer the same exact one, but with the quadratic equation, just to show you how much easier it is. Okay. Questions? Okay, let's get started. So today's the quadratic equation, which is just an equation most of us know already. And I understand that. I'm going to go over like you don't know it, but you've probably seen this before. And the goal is just to get this thing memorized. But I'll tell you, I'm not as much worried about you memorizing it. You're going to be able to do this from the house, right? It's more about simplifying. And that's what students tend to struggle with. And I know we've talked about the simplifying already, and you're going to really kind of see it again. So it's the same issue with simplifying that we had in the previous sections. And I forgot which section that was that we went over this. But I'm first going to start with what our answers are going to look like once we pop it into this formula. And then we're going to simplify it down. So this should look familiar. You've seen this before, but we're going to just do it again. So I'm going to go with the formula first. We're going to go over simplifying. So let's say we get, the answer is going to pop out. The answers are going to pop out looking like this. 10 plus or minus the square root of, let's say, 50 over 20. Okay, we're going to pop it into the formula and we're going to get this answer. And from here, we've got to simplify. Okay, so we're going to go over simplifying this answer first before we get to actually using the formula. So if I want to simplify this answer, the first thing I've got to do is actually look, don't do the 10 divided by 20. I know our brains want to do that. We've talked about this, right? Our brains see the 10 and 20 and they say, hey, that's just 1/2. But no, we've got 3 terms going on here, right? We have to find something that divides into all 3 terms. And look, that 50 is not a 50. It's a square root of 50. It's like 7 point something or another, okay? So you can't divide 10 because that's underneath a radical. So before we get started, we need to see if we can pull anything out of the radical. If not, if we can't pull anything out, we would be done here. We can't divide anything into all 3 fractions, okay? Or all 3 terms. So let's see if we can simplify this 50, which I believe we can. 50 we know is 10 times 5 and 2 times 5. So I can take a 5 out, right? Now I'm left with a 2, but I can take a 5 out. So it's 10 plus or minus 5 square root of 2 all over 20. Okay, so first I've got to simplify that radical. And then now I'm going to look at the 3 numbers that are not underneath radicals. So 10, 5, and 20. And yes, you can divide all 3 of those by 5. And that's how you're going to simplify it. Okay, I'm going to divide all 3 of these by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. I'm not going to write the 1. You can if you want. But it leaves you with the square root of 2. And then 20 divided by 5 is 4. Okay? And I know our brains are going, but 2 and 4 simplifies. I know. But look, all 3 parts have to have something divided evenly into it. And that's not a 2. It's a square root of 2. Okay? Not 2. It's a square root of 2. And we would be done. This would be the final answer. Okay? Questions? Let's do a few more of these. Let's say we've got 2 plus or minus the square root of, let's say, 72 all over 10. And I want you to try that one real fast. So try it real fast. So first you're going to simplify the radical, then see if something divides into all 3 parts. Try that real fast. I'll give you a minute. I'm going to simplify, keep working. I'm going to simplify the 72 first over here. I know that's 9 times 8, right? 8 is 2 times 2 times 2. 9 is 3 times 3. We got a lot going on here. So we can take out a 3. We can take out a 2. Now we're left with a 2, right? So let's see here. If I take a 2 and a 3 out, that means I'm taking a 6 out. Just remember, you multiply them. So 6 square root of 2 all over 10. And then look, we can divide 2, 6, and 10 all by 2, right? Now 2 divided by 2, that's 1. I have to leave it there. It's a placeholder. It's not like where we have a coefficient like up here where the coefficient goes away. if it's the only thing there, you have to put the 1. So divide by 2 on everything. 6 divided by 2 is 3. 10 divided by 2 is 5. Okay? This will be our final answer. There's nothing that divides evenly into everything. Nothing that divides evenly into everything. Okay? Let's do another one. If you've got questions, just ask. I'm going to keep kind of zooming through here. Let's say we've got -6 plus or minus the square root of, let's say, 27 all over 3. So try that one. I'll give you a minute again. Try that one. Okay. So let's look at the 27 first. We've got 9 times 3. I was going to pop out a bunch of 3s, right? Bunch of 3s. Now, we're doing square root, so I can take 1 3 out. And then I've got to leave 1 3 in. All over, now this 3 down here, right? Now notice -6, 3, and 3 are all divisible by 3. So -6 divided by 3, that's going to be -2. 3 divided by 3 is 1, so it goes away. So we just have the square root of 3. And 3 divided by 3 down here is 1. Now you can write it all over 1, that's fine. But you know, with fractions, we don't put a 1 down there. So it's -2 plus or minus the square root of 3. Okay. Okay, and the last type of example we're going to get to, let's maybe do a few. We'll do a few more because I'm telling you, this will be the hardest part once we get the formula down. Let's say we've got. I'm going to give you 2 different ones. Let's say I've got 2 plus or minus the square root of -9 all over 5, and 4 plus or minus the square root of 25 over, let's say, 3. So try those 2. I'll give you a minute. They're a little different. Okay, let's go through here. So first off, -9, we know that's 3i, right? All over 5. And look, remember, we can't add these together. This is a real number and imaginary. They don't add together. And then nothing's divisible by, well, 2, 3, and 5 are all prime numbers, right? So there's nothing divisible by any of those. We're done here. That was a little easier. Down here, though, we can take the square root of 25. That's just 5. So we get 4 plus or minus 5 over 3. So what's different about this one is we can actually add and subtract the numerators. If you go back to every single one of these we've done so far, you haven't been able to add the numerators together, the two terms of the numerator, because we've had a radical left over, right? Well, in this one we can. So we've got to kind of split this up and say it's 4 plus 5 over 3 and 4 minus 5 over 3, okay? So 4 plus 5, that's 9 over 3. That leaves me with just 3. 4 minus 5, that's -1 over 3, right? So we have these two answers, okay? -1 over 3 and +3. Sweet. Questions, comments, concerns? Okay. Let's see here. Let's get to the actual questions now. Okay, or the actual problem. So the problems look a lot like what we did yesterday, just with the completing the square stuff. So if we go back to, let's do that question that Amanda asked me. We'll work one of these out with that question. Ooh, I think it was like 47 or 43. Let me get there. Yeah, like 43. So we've got x squared. You know what? This isn't the best question because I want a different a, b, and c. Let's try a different one. Let's say x squared plus 3x minus 5 equals 0. Okay, so I'll come back to the one Amanda said, but for the first example, I want 3 different numbers as coefficients. So look, this is a quadratic equation because the highest degree term is 0, or I'm sorry, is 2. So since the highest degree term is 2, this would be considered a quadratic equation. And one of the easiest ways to solve a quadratic equation is with the quadratic formula. Okay, and the quadratic formula says, look, if you have any equation in ax squared plus bx plus c, now look, a, b, and c must be real numbers. They got to be real numbers. And a cannot be 0, because if a was 0 here, it would make this term go away, and that's considered a linear equation when the x value is raised to the first power. Okay, so a, b, and c must be just real numbers. You know, like up here, our a is going to be 1, right? Our b is going to be 3, and our c is going to be -5. Okay, now look, 0 has to be on the right-hand side for this to work. Okay, so we've got to have descending order, 0 on one side, and our a can't be 0. So this has to be a number, and then we've got to have, we could have zeros here actually, and it would still work out, but we need 2 numbers here as well. And we can pop it into the formula. Now the formula looks like this. X equals, you start with -b, okay, plus or minus the square root, b squared minus, whoop, I messed up there, 4 ac all over 2a. So -b plus or minus the square root, b squared minus 4ac all over 2a, okay? All over 2a. And we're just going to plug in, and we'll do this example first. We're going to plug the a, b, and c into this equation. So for our quadratic equation up here, if we wanted to solve for the x's, we would have negative, now the b value is 3, -3, plus or minus the square root, 3 squared minus 4 times our a is 1, and our c is -5. All over 2 times 1, right? Our a is 1. And I'll tell you, here's how I do this. When I simplify these, I work under the radical first because I want to get it into what we had just reviewed over, right? If I solve for this radical, then it turns into the stuff I've been reviewing for you guys over the last 15, 20 minutes, okay? So I'm going to look at this radical first. And if you look at the radical, now this is a subtraction sign. So you got to think you've got the whatever is squared minus all these three terms, okay? 3 squared is 9. And now I'm going to take these three numbers and multiply them together. Think of it as -4. -4 times 1 times -5. That becomes a positive 45. Okay? So 9 plus, because we have two minuses, right? -4, -5, plus 45. So this winds up being 54, right? So now my equation looks like this. Now it's -3 because it's negative b plus or minus the square root of 54 over 2. Hey, this is what we've been doing the last 20 minutes of class, okay? This is what we've been doing the last 20 minutes of class. So I'm going to pause right here, and I'm going to ask you if you have any questions at this point. Do you guys have any questions about this formula? Okay. So I've got to simplify this now. Remember, if we're simplifying this fraction, first thing I'm going to do is simplify the 54. 54 is 9 times 6. So 3 times 3 times 3 times 2. I can take a 3 out. 3 times 2 stays over. That's a 3 and a 2. I know it's kind of hard to see there, guys. But that 3 times 2 stays over, so that's a 6 underneath the radical, all over 2. Okay? Now look again, I'm going to look just 3, 3, and 2. Well, there's nothing that divides into 3, 3, and 2, right? So I am done. That's my two answers. Now, it might write, just like you saw yesterday when you did the homework, the book might write it like this: -3 plus 3 square root of 6 over 2, comma, -3 minus 3 square root of 6 over 2. And then there's squiggly brackets there. Okay? It might write it either way.
How will it be done on the test? Will it
You know,
just be,
that's a good question. And I don't remember. If you hang on after class, I can look it up for you.
okay.
But I don't remember right now whenever I was making it, Amanda. And I don't want to make a guess because it'll probably be wrong. Okay, so let's keep doing examples of these. And I'm going to tell you, the quicker you can get into doing them yourself, the better, because you can find out what you're kind of messing up on. Because what I'm going to mess up on is different than what you're going to mess up on, and what your neighbor's going to mess up on. So I'm going to throw another one out here, and I want you to try it by yourself. And it's okay if you get it wrong. We'll just see how we do. But math is not a spectator sport, right? 2x squared plus 14x minus 1 equals 0. Okay, so I want you to solve this with the quadratic equation, right? Remember, it's x equals -b plus or minus square root b squared minus 4ac all over 2a. So I want you to solve that out and see what you get. I'll give you a minute. Ooh. Okay, let's jump in this. So x equals negative 14 plus or minus the square root. B squared, you're gonna have to bust out a calculator for that one. Minus 4 times a times c. Oh, we got the two negatives going on again. All over 2 times a. Okay, so again, I like going over or looking underneath the radical first. 14 squared, I'm sure you guys have already done this, is 196. Now, negative 4 times 2 times negative 1, that's going to be a positive 8. So this becomes 204, right? So we wind up with x equals negative 14 plus or minus the square root of 204 all over 4. Okay, so 204, let's break that down. Now it's divisible by 2, right? 102 times 2. And this would be, what, 51 times 2? And 51 is divisible by 3. That's 17 times 3, right? So, but there's our prime numbers. So I can take a 2 out. So we get x equals negative 14 plus or minus, take the 2 out, and I'm left with 17 times 3, which we know is 51, all over 4. Okay? Questions? Now I can divide the 14, 2, and 4 by 2, right? I mean, these are all even. So I divide those all by 2, and I'd have negative 7 plus or minus the square root of 51 all over 7. Boom. Okay. Questions? Oh,
I'm lost on the 7 on the bottom.
you know what? I would be as well, because there shouldn't be a 7 on the bottom.
Okay.
4 divided by 2 is not 7. Boom. There you go.
Okay. Just making sure.
Thank you for following along. Okay. Yeah, let's do another one. Okay, so let's say we've got, I gotta change up the signs here. I'm gonna steal, this one actually is from your book. It's actually an 8.1. It's 62. So 4x squared minus 2x equals negative 5. I'm going to tell you, the reason I chose this one is if you want to use the quadratic equation, you have to move the 5 over. You have to have a 0 here, okay? So I'm going to move the 5 over. So I'll get 4x squared minus 2x plus 5 equals 0, okay? Try that one. I'm going to give you a minute to try that one. Okay. So Amanda, to answer your question, it separates it. So we'll do that on this one. That you're asking about the test. I looked it up real fast. It separates it out. It doesn't make it one answer. So we'll write those like that.
Okay.
Okay, so let's do that. X equals negative b. So now we have negative 2, right? Plus or minus the square root b squared. Now be careful, you got to make sure you square the negative. That's a minus sign. B squared minus 4 times a times c all over 2 times a. Okay, so underneath the radical, we get negative 2 squared. That's a positive 4. But then we have negative 4 times 5. 5 times 4 is 20. Times 4, that's 80. So it's going to be minus 80, though, right? Because it's negative, positive, positive. So it's going to be a minus 80. So that winds up being negative 76, right? Yep. So we get x equals positive 4 plus or minus the square root of 76. Oh, negative 76 all over 8. Okay. So now we've got to break down the 76. So 76, it's divisible by 2, right? It's 38 times 2. And then 38 is 19 times 2. So I can take out a 19, and now I'll also have to take out an I, right? Because it's negative. So this winds up being 4 plus or minus 2, and then it's negative, so I, square root of 19, all over 8. And then look, 4, 2, and 8 are all divisible by 2. So we get 2 plus or minus I squared of 19 all over 4. And so on the test, it splits this up. So it's going to be written as 2 plus I squared of 19 over 4 and 2 minus I squared of 19 over 4. Okay.
Question about this one.
Oh, did I make a goofy mistake again?
Well, I'm just curious here because on a previous one, because of the imaginary number, we couldn't divide.
Oh my Lord! Wait, time out. Wait, time out. Hold on. First off, I don't know where I got this 4. I'm making all kinds of goofy mistakes. So this, when you divide this 2 by, look, you see that? So that should be 1 here. Okay, there we go. Is that what you're going to ask, Amanda?
Well, not really, because
Okay, good, because
I didn't even catch that.
I'm listening. I'm sorry.
The 2i, I thought we couldn't divide by that since it's an imaginary number.
Oh no. You can divide. You cannot add or subtract.
Okay, that's where I got confused then.
Yeah. No. If you wind up with something like, 2i divided by 8, you can simplify this. This would be just 1i over 4. Okay.
Okay.
But if you were trying to add 2i plus 8, not gonna happen.
Okay.
Yeah. I see what you're
So
saying.
what about multiplication? Does it work with multiplication as well?
Really, division and multiplication are really the same thing. So it's 2i times 8 would be 16i. Yeah.
Okay. So just adding and subtraction, it won't
Adding
work.
you cannot do because it's a real and imaginary.
Okay.
Yeah.
All right. Thank you.
No problem. I mean, think of it kind of like an x. Really think of it like an x. If this was 2x over 8, you'd be like, oh yeah, that's just 1/4 x, right? But then you couldn't add 2x and 8, right? Like 2x plus 8. Same kind of, like if you think of them like terms, like a variable, it follows the rules of variables. Okay, let's do a few more that have kind of different outcomes. And I'm gonna, you know what? I'll give you two different ones to show you. The first one, let's say, is x squared plus 8x plus 15 equals 0. So try that one. I'm going to look for another one here that has a kind of goofy outcome. Let's say we had 4x squared minus 20x plus 25 equals 0. Okay. So try those two. I'm going to give you a little more time. And that first one definitely is going to take a little more time. it simplifies a little more complete. I'm gonna start on this first. Okay, x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Okay, so underneath this radical, I get 64, 8 squared, minus 15 times 4 is 60. So minus 60, so I get 4. So I get x equals negative 8 plus or minus the square root of 4 over 2. And I can take the square root, so I'm going to just kind of keep going to the right here. I can take the square root of this, so negative 8 plus or minus 2 over 2. And then because I can now add and subtract the tops, I have to split this up. So I get negative 8 plus 2 over 2 and negative 8 minus 2 over 2. Negative 8 plus 2, that's going to be what? Negative 6 over 2. So that's negative 3. Negative 8 minus 2, that's negative 10 over 2. And that's negative 5. Boom. Okay, so this one simplified completely. Now what this means is if you can take the square root, you could have factored this from the beginning. It would have been a lot easier to solve for, right? 5 times 5 adds up to 15. Here, look, if you would have factored this, it would have factored in a 5 plus 5, 5 plus 3, right? Set each one of those equal to 0. X plus 5 equals 0, x equals negative 5. X plus 3 equals 0, and x equals negative 3. So you could have solved it the other way we went over at the beginning of the semester because it was factorable. Now, I'll tell you, not a single one up to this point that we've done has been factorable, okay? And the ones I gave you on the final, they're not factorable. If I ask you to solve it with a quadratic equation, they're not factorable, okay? So, but you might come into this in the homework. It's just good practice, and it keeps going, boom, 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 all the way down to just basic integers. Okay, so now let's do this bottom one. Okay, so we got x equal negative b. So I'm just going to put that's 20 plus or minus the square root. Negative 20 squared minus 4 times a times c all over 2 times 4. Now underneath the radical here, negative 2 or negative 20 squared, that's 400. 4 times 4 is 8 times 25. Well, that's 8 quarters, right? No. 4 times 4 is 16. 16 times 4, that's 16 quarters, which is 400. Oh, wait, this is minus 400. Right? Huh. Well, that's just 0. So x equals 20 plus or minus the square root of 0 all over 8. Now, if we follow along, look, the square root of 0 is 0, right? And you can take 20, you can add 0 and subtract 0, you'll get the same thing. So for this one, that 0 goes away, like zeros do. And you just get 20 over 8, which simplifies. They're both divisible by what? 4? So you get 5 halves. So just one answer. Now notice every single solution up to this point has been 2 solutions, actually. This one, if you get 0 underneath the radical, you wind up with just a singular solution, okay? Just a singular solution. And the technical thing that's happening is we have repeated solutions, okay? I know that's goofy. We'll hit that more in college algebra.
I have a question.
Yes, ma'am.
I didn't get 5 over 2. I got 2x and negative 5 for the answer. So I'm not sure where I messed that up.
Well, there's no x's there's no x's over here.
Oh, okay. Then that's probably, oh, I wrote it wrong. Okay.
Yeah. You're never going to have an x on the right-hand side over here, ever. Because you're only plugging in numbers, Letitia.
I got you. Yeah, I wrote it wrong.
Oh, okay.
I wrote it 4x, and I looked at when it's 4 times 25, and I think I looked at it as an x, is what I did.
I got you. Good question. Do you guys have any other questions? Okay, let's do one more. Now this one's gonna look goofy at first, but I promise it gets easier. Don't tune me out just because I chose it. This is number 14. 1/6 x squared. This is from the homework today on page 607. 1/6 x squared plus x plus 1/3 equals 0. Now I know you guys don't like fractions. I don't like fractions either. Okay. And the first step we have to do is get rid of the fractions. So just like whenever we simplified complex numbers or complex fractions, we're going to multiply every single one of these, every single term by the common denominator. And look, the two denominators are 6 and 3. So the LCD here, the LCD is just going to be 6. So I'm going to multiply every single term by 6. Okay, now when I do that, so I'll kind of make an in-between step. I get 6 over 6x squared plus 6x, right? 6 times x, plus 6 over 3 equals, well, 0 times 6 is just 0. Okay, so what happens here, these fractions will cancel or they'll simplify. 6 over 6 is just 1, so that leaves me with x squared. 6 divided by 3 is 2. So it leaves me with 2. So just like simplifying complex fractions, if you come to a fraction, like a fractional a, b, or c, the very first thing I would do is just multiply every single thing by the least common denominator. And what it'll do is it'll put it into a nice equation. Okay, it'll put it into a nice equation. Now I want you to try this one though. I'm going to pause right here and you just try this one and simplify it out. Okay, let's go through this. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a, right? So underneath the radical, I get 6 squared, that's 36, minus 8, right? Negative 4 times 1 times 2, all over, oh, wait. Not all over, good Lord. 36 minus 8 is 28, right? Yeah, 28. So we get x equals negative 6 plus or minus the square root of 28 over 2. Now, I do need to bring down the 28. It's 14 times 2, 7 times 2. So I can take a 2 out, right? This is not showing up. This is looking weird on the camera. I wonder if I do some. Nah, it's just, I'm going to put this marker up. So you get negative 6 plus or minus. I can take a 2 out, but I'm left with a 7 underneath, all over 2. How does it look more out of focus after I hit the focus button? There we go. Okay. So we can simplify all of these, right? We can divide all these by 2. Negative 6, 2, and 2. They're all divisible by 2. So I'd have negative 3 plus or minus the square root of 7. Now, again, if you want to write this over 1, that's fine. But realize the two answers are going to look like this. Negative 3 plus square root of 7, comma, negative 3 minus square root of 7. Okay? That's what the two answers are going to look like. Okay? Okay, do you guys have any questions? I mean, I've hit all the different types of answers. So do you have any questions for me before I give you the homework? Okay, great. So for homework, it's on page 607. And I want you to do 1 through, 1 through, let's do 1 through 31 odd. So it's not that much, about 15 questions. So 1 through 31 odd on page 607. And then tomorrow when I get here, we will have a, yeah, that's my talent. We had a, we'll have a review day before the final. Okay. Great. So I will see you all tomorrow. Have a great day. If you have any questions, let me know.
I actually forgot to ask a question.
Okay, what's up, Amanda?
I was having trouble on number 39, and I don't know what I was doing wrong.
This is from 8.1.
Yes.
Okay, let me pause the live video thing.